Okay, we're going to talk about power. So we have two different equations for power up there. Power it's how fast work gets done. It's work divided by the time interval in which the work occurs. It's also the force that's applied and the velocity it's applied at. You can do the dimensional analysis to prove that those two things are basically the same. Because, of course, velocity is what? Displacement over distance. Force times distance is work. So, do you want to see that? You need to see that? Okay, let's see that. Okay, so you know that work equals force times distance, therefore power equals force distance over time. If we look at distance over time, what is that? Why, it's velocity. So, therefore, power also equals force times velocity. So, make sense? A little bit? Be great for calculating things like getting hit with a baseball. Yeah, it is Newton meters per second. No, there's more to it than that. Because force is, yeah, Newton meters per second, and a Newton is a kilogram meter per second squared. So it'd be kilogram meter squared seconds cubed. Yes. But we're not going to go there. We're just not going to go there. And the unit is the watt, 1 joule per second. 1 watt is 1 joule of work being done in 1 second. And yes, 746 horsepower, or 746 watt is 1 horsepower. So that's quite a bit of power, actually. We have a 193 kilogram curtain. It needs to be raised 7.5 meters at constant speed in about 5 seconds, and we've got 3 motors to choose from. If you go to someplace like Star Supply or the Restore, you're going to find bunches of little, 1/3 horsepower, half horsepower, 1 horsepower electric motors. So it's kind of similar. We have a 1 kilowatt, 3.5 kilowatt, and 5.5 kilowatt motor. Which motor should we choose? The variables that we are given, whoops, redo. The mass of the curtain is 193 kilograms. The desired time is 5 seconds, and the distance that this thing has to move is 7.5 meters. So if we think about, we're going to think about the curtain as just a point object, and if we think about raising it at constant speed, so there's no acceleration, that's important, because it means if you're raising it at constant speed, what is the force required to raise it? Same as the force required to just hold it still. It would be the mass times gravity. So what we want is to find out how much power our ideal setup would have. Power equals work over delta T, which is equal to force distance over delta T. I'm going to shrink all this. And that, whoops, somehow I missed a bunch of stuff there. And the force that we need, we know, is mass times gravity times the distance all over delta T. So given that, we can plug in our 193 times 9.81 meters per second squared. This is, of course, kilograms. I got sloppy there. Times 7.5 meters, all divided by 5 seconds. Okay, we get a raw answer of 2,839 and change watts. The motor ratings that I was given were in kilowatts. So if we say this is 2.8 times 10 to the third watts, guess what 10 to the third watts is? 1 kilowatt. So the ideal motor for me would be a 2.8 kilowatt motor. I don't have a 2.8 kilowatt motor. My options are, what, 3, 3.5, 5.5, and 1. So the 3.5 gets you pretty close. The 1 kilowatt motor isn't going to lift it fast enough, and the larger 5 kilowatt motor is going to go too fast. So the 3.5 is the one you would want to use. Fairly easy stuff. If you were going to try to do a bonus problem on a quiz, I would write down the formulas for power on your note card. That would be handy. So. This is just me being nosy, because we mentioned that 746 watts equals 1 horsepower. No, no, I'm never going to ask you that because horsepowers are stupid because they're not an SI unit and they're, you know, like 746 of them. Are you kidding, huh? It's an old imperial unit, so Europe and the U.S. used to all use imperial units. We're the only ones left, like us and one small island in the Pacific still use imperial units. So let's figure out a 1/3 horsepower Freedom units. Don't get me started. 0.33 horsepower engine is how many watts? So 1 horsepower. So, okay, yeah, okay. Well, that's not all that hard. This in round numbers. So if you had a 214 watt motor, 248. Okay. 248.6 watt motor. That would be about a 1/3 horsepower motor. Okay, look those over on your own. Test is tomorrow.